In addition to the homework, I'd like you to have out your pencil, your reference table, your calculator, and your notebook. We have two things we're going to accomplish after we go over the 2 pages in your packet that you did for today. We're going to keep working on Unit 2A, doing more example questions together. And then we're going to take a break from that and start a lab where I want us to be able to collect some data. It's an in-person lab that we do, not a virtual lab. We collect some data using some toys, and we'll put that into a Google Sheet so we can analyze the data and learn more for our next section, Section B, that will start next week. I think I asked you to bring a ruler and protractor to class today. I've modified what I was going to do a little bit, so that will be needed in class tomorrow and every day thereafter. So please make sure that starting tomorrow, you have a ruler and a protractor here in class. If you have it today, you can put it away. You won't be needing it today. You'll need it tomorrow and every day after that. Okay? So let me come around and check the homework. There is no written assignment for tomorrow other than to study. The only thing I want you to do for tomorrow is study Unit 2. Looks like I'm going to have to start making some phone calls home. A lot of you are starting to slip with homework. Not good. Not okay. You're losing 10% of your grade in this class. It means the highest grade you could possibly earn if you do everything else perfect is a 90. I don't know anybody else that's that perfect to be able to achieve that. Especially when you had 2 nights to do it. It was like a 5-minute assignment. Question number 1. What is a displacement? Define it in your own words. A displacement is just a change in position. We have that in our notes already. Number 2, if you wake up in the morning, you go to school, you go to the grocery store, and then you return to the same place where you woke up, what was your displacement? It's 0. Why? Because your initial and final positions are exactly the same. And displacement is a change in your position. You didn't change your position. Yeah, that's fine. 0 of anything. No, there is a solution. The answer is 0. 0 meters or just 0. No, that's how I write a 0, so it doesn't look like an O. Okay. Number 3, what kind of quantity is displacement? It's a vector, has a magnitude and a direction. Can your displacement be negative? And if so, what does the sign indicate about the displacement? Yeah, it can be. And that's because displacement's a vector. So the negative sign is a direction. That negative sign tells you that you either moved left, down, west, or south. We don't know which one, but it's one of those negative directions. Number 5, can a distance ever be negative? No, that's because distance is a scalar measurement. It would be like saying that you have a shirt size of negative medium. If I asked you for the size of your shirt, would you say negative medium? Would you ever even say positive medium? What do you say? Just medium. That's size. No sign at all. So by putting a sign, whether it be positive or negative, you're telling me it's now a vector, not a scalar. Number 6, if someone told you that they went 50 kilometers east, are they describing the distance or the displacement? They're describing a displacement, and you should know that because they gave you a direction on that measurement, east. So that's a vector. Number 7, when will an object's displacement and distance traveled be different? Whenever you change direction as you're moving. If you change your direction of travel, your distance and displacement will be different. Number 8, draw a vector diagram for a person that goes 3 meters north and 5 meters east, and how would you determine the displacement for this person? All right, so here is my vector diagram. Notice that I am putting arrowheads on all 3 sides of the triangle. You need arrowheads on them, otherwise they're not vectors. There's no direction. So first we went north, which is upward on our paper. Make sure you have an arrowhead that goes up. That is your 3 meters. Then we turned and went east. That's to the right. So arrowhead pointing to the right. That's the 5 meters. Our displacement is that hypotenuse that points to the ending location. Again, there's an arrowhead on it. That's the displacement, which is the hypotenuse of this triangle. First thing we have to do is find the magnitude of it. We find the magnitude of the displacement using Pythagorean theorem. A squared plus b squared is c squared. So we would do 3 meters, that amount squared, plus 5 meters, that amount squared is the displacement magnitude squared. So we get a displacement to the nearest meter, which is 6 meters. That's its magnitude. But since displacement is a vector, you're also going to have to give me the angle, the direction from the positive x-axis, which is here. There's my positive x. The angle rotates around until we get to the displacement vector itself. It's this angle. This angle is outside the triangle. But in math class, you've learned that this angle is the same as that one. These are called alternate interior angles or opposite interior angles, and therefore they are congruent. So to find this angle, it's the same as calculating that angle. And in class, we've already talked about how to find an angle in a triangle when you know the 2 sides of the triangle, the 2 legs. We use the inverse tangent equation. So the angle, the direction, is the inverse tan of the opposite over the adjacent side. So the inverse tangent of, therefore, the opposite side of this angle is 3 meters. That's the side that opens up when we change that angle, 3 meters. Divided by the side next to the angle, that's the top one, that's our 5 meters. The meters cancel. We then go to our calculator. We type in second tan, 3/5, enter, and to the nearest degree, that gives us a direction of 31 degrees. So the final displacement for this person you should have written was 6 meters, 31 degrees, and that is the only acceptable answer to that problem. But we start with a sketch every time. Any questions on that problem? Yep.
How do you know if it's like you know how that angle on the right or the angle on the left?
This one and this one? This is the one we want.
No, how do you know that's the one you want, compared to that? You know how it makes the right angle,
yeah, so you could have found this one, but then you'd have to take that away from 90.
Yeah, but how do you know that one? Is it always going to be the one that's?
You always want it starting at the positive x. In our notes, I'm going to go back to my notes that I have here. This way you have your notebook out, right? Let me see where the page is. We talked about direction. 3 ways to find direction. 2. This is 3. Where's my page 1? It's right here. Whenever we come up with an angle measure, we said what we have to do is always measure from the positive x-axis and go around the origin counterclockwise. So where is the positive x-axis in this picture? It's here. That's why I have to rotate around there. And that's how I know it's that angle, because that's how it's defined. Okay. All right. And lastly, number 9, what's a time interval? A time interval is just the amount of time between your start and end positions. How long did it take you to go from your starting point to your ending point? How long does it take you to go from A to B? So on this picture, I would not time it from here to here. I would time it from here up and over and stop it there. You follow what I'm saying? From start to end. Even though I didn't follow a straight line, the time is measured from the start point to the end point. Okay, any questions on the homework?
I guess in general, when you put your capital in grading,
You're never going to use radians in this course. Never, ever. I can't speak to other courses because I don't teach them. Okay. All I can tell you is in Regents physics, it's all degrees, always. Okay. If you were to come back next year and take the college physics with me, advanced placement physics, then we go back and forth. And then you'll learn how do you know what to do when. But this class, it's always degrees. Okay, let's shift ahead now that we've gone through all the homework. Please go to page 4 in your packet. And we're going to look at problem number 5. Did it turn green? Okay. If it doesn't turn green, then I... All right, number 5. We're going to keep working with this. You have all that stuff out because in a minute, once we finish page 4 in the packet, then we're going to go back to our notes and do a few more examples in there. So number 5 says, when we look at a map, a student realizes that Birmingham, as in Birmingham, Alabama, is nearly due west of Atlanta. That's it in Georgia. And Nashville, that's in Tennessee, is nearly due north of Birmingham. So way too many things right there. We need to sketch that out. Where are these 3 cities? So if this is Atlanta, I'm just going to use an A for Atlanta. Birmingham is due west of that. That means it's to the left. That would be Birmingham with a B. And then where am I going to put Nashville in that picture? Above what? Right above Birmingham, right there. I'm going to label that N for Nashville. Now it tells you that the distance from Atlanta to Birmingham is about 150 miles. So this distance right here, let me put it right in between those 2 dots instead of below it. This distance here is 150 miles. And the distance from Birmingham to Nashville, that's that distance right there, is roughly 200 miles. I want to know what's the estimated distance from Atlanta to Nashville. That means I'm looking for that right there. What is that side of the triangle? What is that distance? How are we going to find that? What equation are we going to write? Jackson? Very good. A squared plus B squared equals C squared. Let's go ahead and plug in 150 miles squared. MI is the abbreviation for mile. Plus 200 miles. That abbreviation or that amount squared. Make sure those are in parentheses. That's equal to the distance you're looking for squared. Don't worry about sig figs. How far is Atlanta from Nashville if we go direct? There you go. 250 miles would be correct. Everybody getting that? Okay, let's go to number 6. A local sign company needs to install a new billboard. Now the signpost is 30 meters tall. Could you please make that 30 meters tall? And the ladder truck is going to be parked 24 meters away from the bottom of the post due to an uneven ravine. All right, so here is a ravine. There is the signpost. We know this signpost is 30 meters tall, and we're going to put a truck right here. That's our truck. This is 24 meters, according to what they told us in the question. How long is the ladder on the truck? It's a ladder truck in order to reach the top of the signpost from that distance. Let's call that ladder L. What is the length of that ladder? What are we going to do to find the length of the ladder? Who can tell me what equation are we going to use to find the length of the ladder? Should be pretty easy. All right. Very good. We're going to, yeah.
So why do you draw the arrowheads and then
So in this case, I'm just showing a distance between these two marks. That's a convention. If you didn't want to put the arrowheads on that, that's fine. Arrowheads usually indicate a direction.
so why was it required like on the homework?
Okay. On the homework, it was required because it said to make a vector
Okay.
diagram, right? Vectors have to have direction. These amounts are not directions. They're just distances. So they really wouldn't have it. Okay. So now we're going to go ahead and plug in. So 30 point meters, that amount squared, plus 24 meters, that amount squared is the length squared. What is the length of that ladder? Let's go to the nearest meter. Do you see how both of those values go to the nearest meter? I want your answer to the nearest meter. Eric, you got it?
30.
No, it is not 30 meters. Can't be 30 meters. If it's 30 meters, then this is not a triangle that we can draw. Joshua. There you go. 38 meters is correct. 38 meters. So when I work that out, watch the math. 30 squared plus 24 squared. Enter. Now I got to take the square root of that. Second, square root, second, answer. Do you all have an answer key on your calculator so you don't have to retype a darn thing? When you hit that and it says ANS on your screen, it means it's taking the previous answer and plugging it in for you so you don't make an error mistyping it. And there's my answer. Nearest meter gets me to 38 because the next digit's a 4. 38 meters. All right, number 7's the most complicated one here. In order to hike around a portion of Lake Allatoona, all right, Lake Allatoona is in Georgia. Let's say this is the lake. Lake Allatoona. A tour guide determines that he must take his group 150 meters to the east. So let's say he starts here. He brings his group to the east 150 meters. Let's make that 150 point meters, please, so we can do everything to the nearest meter. And then he has to go 60 point meters north. North would be straight up. This is going to need arrowheads, right? Because we have directions on them. So 60 point meters north. And then he's got to go back 75 meters to the west. I want to know what is the displacement of the tour group from its initial position, I is our initial position, to its final position on the opposite side of the lake. That is our final position right there, where the F is. Now, if you look back at the previous questions, everything we've done has formed a what? A triangle. Do I have a triangle right now? No. And in fact, if I want the displacement on this picture, I'm going to draw it in red so you can see it. The displacement, and I'm just using a straight edge so it looks nice. You don't have to do that. The displacement would be right here. And it always points to our ending location there. So there's an arrowhead on it, and that is the displacement that we're going to look for. That's definitely not a triangle. It's a four-sided shape. It's a trapezoid. So what we now need to do, in order to solve this, we have to make a triangle. Could you make a right triangle in that picture somehow? Yeah? What are you going to do? What could you do to make a triangle in that picture? Joshua? You want me to draw what? Extend this? No. Nope. That won't end up making a triangle. I mean, you could go all the way up, but I want to find that length. So I don't want to change that. Alan? Eric? Yeah, so what we can do is just drop a line right here. I'm going to draw in these sides in blue. Do you see them? You see my right triangle now? Okay. Let me label those sides. How big is this side of the triangle that I'm pointing to? 60 point meters. How big is this side of the triangle? Yeah, it's 150 minus 75. You went forward or to east, 150, you backtracked 75 of that, leaving us with 75 meters to the east, 60 meters north. Now you have a right triangle. So now we can find that displacement. Let's find the magnitude of it first. What equation are we going to write to give us the magnitude of the displacement? Shane? I'm sorry? That's not an equation. Keep going. A squared plus b squared. There you go. Now you have an equation. If you leave off the equals c squared on a test, you don't get any credit because it's not an equation. You don't have the e step that's required in the guess method. A squared plus b squared equals c squared. In other words, we're going to do 75 meters squared plus 60 point meters squared. That's going to equal the magnitude of our displacement squared. Do you notice that both values go to the nearest meter? I want yours to go to the nearest meter as well. So go ahead, figure out what that is. How many meters is the hypotenuse of that triangle? Bryce? 96 meters is correct. Now, displacements are vectors, which means not only do I need to know the magnitude, I now need to find the direction of the displacement. And we talked about that in class. We've also talked about it. You had to do this on the homework for that one question. You have to say, where's my positive x? What direction, what compass direction is associated with the positive x direction? East, right? The compass rose, east. This was the east here, which means I would start at the east and I would rotate around until I got to the displacement vector. That arc inside the triangle is the angle I'm looking for, that theta. What equation am I going to write to help me get theta? So the angle is the inverse tan of the opposite over the adjacent side. So let's go ahead and substitute in. That means I'm going to do the inverse tan of what? What over what? 60 point meters over 75 meters. The meters are canceling, and angles always go to the nearest degree. So let's make sure we can get that to the nearest degree.
What's the difference between like if you just the right answer?
That's not going to give you an angle. Tangents are done if you already know the angle. The tangent of an angle can be used to help you get one of the sides. Okay. Here, when you want the angle, you always have to undo the tan. You got to get the tan detached from the theta, which is the inverse tan. All right. So what is that angle to the nearest degree? Mohammed, do you have it? Good. This means, and we're going to put our final answer over here, that the displacement is 96 meters, comma, 39 degrees, and we can box that in. That is our final answer to that question. Now, this is all fine and dandy when we're doing problems in the first quadrant. Remember, first quadrant are any directions between 0 and 90. you're not always going to have things that go east and north. You're going to have things going maybe west and north, or west and south, or east and south. So that's what we're now going to tackle back in our notes. I'm leaving page 5 and 6 with your ruler and protractor for tomorrow. So let's go back into our notes. This is why we have our notebook out. And we're going to try some additional example questions with these displacement vectors that are not in the first quadrant. Now you've got your reference table out. I neglected to have you check off the equations we use when we're doing these right triangle type of problems. These are under geometry and trigonometry. And here is our right triangle. So here is your Pythagorean theorem that you're going to use whenever we make a right triangle to find one of the three sides. And the other one we're always going to use probably is our tangent. And if you'd like to, for your notes, you can show that the angle that you're looking for is therefore the inverse tan of A over B in this picture, where A is our opposite side, B is our adjacent side, and C is our hypotenuse. So those are the equations that we're using now because we have right triangles. They only work if it's a right triangle. You can't use this for any other type of triangle but a right triangle. And that's why we're going to need rulers and protractors tomorrow, because we're going to have questions that are not right triangles. What do we do then? So let's look at this example. Let's say that we have a hiker who went 4 meters to the west and then let's say 6 meters to the north. I want to know what is the displacement of this hiker. We're always going to make a sketch. So I'm going to show my XY coordinate axes in a sketch. No rulers or protractors. Here's my positive X. West on this picture would be which way? Left. So we start at the origin and we draw a nice arrow pointing to the west, and we label that our 4 meters. That's the 4 meter west vector that we were given. Now we have to go 6 meters north. Which way is that? Straight up in this sequence. Notice that has an arrow on it as well. Why? Because I gave you a direction with it. We got to show that it went north, not south. Now the displacement in this picture starts at our origin and goes to the tip of our final vector. That arrow away from the origin is the displacement vector that we're looking for. So the first thing we're going to do is we're going to find the magnitude of that displacement vector. How do you find the magnitude of that displacement vector? So you're going to write the equation. A squared plus B squared equals C squared. You're now going to plug in 4 meters, that amount squared, plus 6 meters, that amount squared. That's our displacement squared. So what is the magnitude of this displacement? Yeah, nearest meter, because those are the nearest meter, we're going to say 7 meters. That's only half the answer we need. We now need to find the direction of this displacement. Okay. First of all, what quadrant is that displacement vector in? Second quadrant. It's pointing up and left into our second quadrant. This is a quadrant 2 direction that we're going to need, which means that our angle is somewhere between, the direction is somewhere between what points up, which is 90 degrees, and what points to the left, which is 180 degrees. Our answer has to be somewhere between it because it's pointing up and left. Now remember the rule for where we measure the angle from. Where do we start measuring the angle from? Always. No, we don't start at the origin. We need a line, the positive x, and we go around the origin in a counterclockwise direction. That's the angle we're going to need. We have a problem though. Is that angle inside the triangle? Which means you can't calculate it in one step. This is a two-step problem. In order to find that angle, you have to start by finding an angle inside the triangle. This one right here. You see that double arc? We always calculate angles inside triangles, not out. At least to start with an equation. Let's call that angle alpha. Alpha is what we call our reference angle. To get that, we're going to use our inverse tan. We're going to do the inverse tan of whatever side was opposite that angle over whatever was adjacent to it. That means in this problem, we're going to do the inverse tan of 6 meters over 4 meters. So the meters cancel. We find an angle inside the triangle. We then go to our calculator, we type that in, and we get an answer to the nearest degree. Nathan, do you have it? Not yet? I'll give you a minute. What is that angle to the nearest degree? What mode are we using our calculators in this class? Always degrees. Okay. Now, if you notice, that obviously can't be our direction because 56 degrees is not in the second quadrant. We need it to be. So here's where you have to think a little bit. The angle I'm looking for is this one. And this amount here is 56. But remember, this line is 180. I have to back up by that 56 to get where I need to stop. Any idea what we have to do then to get this? What'd you say? From? Yeah, we're going to do 180 degrees, which is the west reference line, and back it up by the angle we just measured. So that's subtract 56 from it. What does that mean the direction of this vector is? What is it? 124 degrees. So that is right in that range where I need it to be. So our final answer for this displacement is 7 meters, 124 degrees. That's a quadrant 2 problem. We're going to do one in quadrant 3 and then one in quadrant 4 to make sure you understand what has to be done, okay? Can I go on to quadrant 3? All right. Let's say we're going to go 10 meters west and then 5 meters south. I want to know what's the displacement. So first thing you do, sketch it out on your XY axes. West is to the left. So an arrow pointing left. This is 10 meters in length. And then we're going to go 5 meters south. That's pointing down 5 meters. So the displacement we want is this arrow right there. I want to know not only its magnitude, but its direction as well. Always start by finding the magnitude. That's the easy part. Find the magnitude of the displacement. Hudson, can you tell me what equation I should write? Very good. So we're going to plug in 10 meters squared plus 5 meters squared is this displacement squared. What is the magnitude of that displacement? We're going to go nearest meter. These both went to the nearest meter. Lila, can you tell me what you get? 11 meters. Good. Now we're going to find the direction of this displacement vector. This is in what quadrant? 3. Quadrant 3. Angles in quadrant 3 are somewhere between 180 and 270 degrees. So the angles between 180 and 270 degrees. Again, you can't calculate it in one step. But you can find the angle that touches the horizontal, that reference angle alpha. How do we find that reference angle? Yeah, we're going to say that alpha is the inverse tan of the opposite over the adjacent side. So we'll plug in. What side is opposite that angle? 5 meters, yep. And the adjacent side is 10 meters. We go to the nearest degree. Jacob, what'd you get? 27 degrees is right. Is correct. I shouldn't say it's right. Right is 90. Right angle, right, 90. Okay. I gotta be careful when I use my words because there's a lot of math stuff in here. Now, what am I going to do to come up with the angle I want, which starts here at the positive x? We start at the positive x, put your pencil there, and you rotate, go around the origin counterclockwise until you hit the displacement vector, which is there. That's the angle I want, that big arc. Notice you just found this little piece of the big arc, right? Yeah, you're going to add the 180 because from here to there gets you to the 180, and we are going beyond it by that 27 degrees. So the angle we want is 180 degrees plus the 27, which means the direction is 207 degrees. So our final answer for the displacement, the way we write it, is the magnitude first, 11 meters, comma, and then the exact direction, which is 207 degrees. Make sure you put a degree symbol after that. If you don't, you mean 207 radians. That's what it means without the degree symbol, which is not the same as 207 degrees. Okay, can we do one more? Make sure we're really good with this. Let's say this person walks 3 meters to the east and 7 meters to the south. What is this person's displacement? Do you think you could do it by yourself? You want to give it a try? You're doing this in pencil. I'm going to freeze the screen. I'm going to let you try to work it out. And then we'll compare. I think that's probably better. See if you can work the whole problem out. Check out all your work. All right, let's take our break. When you come back, I'll give you a few more minutes to work on finishing this one, and then we'll check. Uh-huh.
It's like difference of y.
You could say y over
I
x.
used to do it every time.
Yep, you can write y over x. Or if you prefer, you can write o over a. Hey, let's head on over here. This is your test here. And I'm going to clean reference data for you. Don't worry. Anything I need to write but you can write all over this. Everything should be on this pen. So this graph, this graph here, and this All right, let's finish this up. That way we can get to lab 4 and have some fun. All right, who needs more time to keep working on this question? All right, let me give you a couple more minutes. Just a couple. See if you can wrap it up, and then we'll check your work. Make sure you're doing it in pencil, so if you make a mistake, you can fix it in just a minute. Hopefully you don't have mistakes. Hopefully you're not missing anything. Make sure you showed all those steps like you were told to. Yeah.
Why is it like not giving me the answer?
I don't know. I don't know what kind of mode this is.
It's ended green, but it's
No, but that's not going to help it. You're like in a fraction mode or something. So we have to get your normal floating point. Oh, let's go to classic. All right, try it now. Okay, so what do we have to do? The square root?
yeah, the square root of 58.
There you go. That was it. You're welcome. Okay, I'm guessing by all the talking that we're done. Y'all have it? So I could take somebody's paper and bring it up, put it on my document camera, and we grade it? Who wants to do that? Mohammed, you want me to do it? You said yes? All right, let's do it. Oh boy, no. Yours is too hard to read, and I can tell you there's too many mistakes. All right. On the right? Yeah, you're missing a bunch of stuff too. Yours does not look like the teacher copy. So I want to know who thinks they have everything. Good job. All right, let's look at it. Doesn't mean it's perfect. I might find something, but let's look. Okay. So first thing, sketch. Did you sketch it? 3 meters pointing right, 7 meters pointing down. The only thing we're missing on here, Josh, and I'm going to fix it with my red pen. We need an arrow on this side of the triangle. That is your displacement D. You label it D with the arrow, okay? So everybody should have a sketch that looks like that. First, we're going to find the magnitude. Did you write the equation? I saw a lot of you not writing the equation down. You get 0 credit on the Regents exam unless you write that equation down. I can't grade it at all without the equation written down. This is constructive. This, like yesterday, you just took a test yesterday. And I think I told you you had to write equations for everything. It said show all work including, and the equation was listed. You didn't show it, guess what? Points gone. If you get sloppy and you don't follow directions, I'm taking points off. It's not about the physics. It's about, can you follow the directions? This test that you're going to take in June is not a hard test, but it is picky about every little thing. So if you want to be sloppy, you're not going to do well. That's what's going to prevent you from getting a good grade on the Regents exam is sloppiness. I'm setting you up for that now. I'm going to be picky all the way along so that way in June, I'm not throwing all these new rules at you. They are the same rules we're going to follow a year. A squared plus B squared is C squared. I love, Josh, that you have parentheses around these values with the units. Without it, it's not correct. The substitution's wrong. Otherwise, you were telling me you had 3 square meters. That's an area. You have to square the 3 and the meters. You have to square the 7 and the meters to give you the displacement squared. So the displacement is 8 meters. That has the right precision and everything. Very good. Now to get our direction, he's finding the angle inside the triangle first, alpha, by showing the equation for it. Alpha is the inverse tan of adjacent. You must start with an equation. If you do not write that, you do not get any credit. It's all wrong. So alpha is the inverse tan, and I love that you put the units on these numbers. They got to be there, 7m over 3m. The calculator will give you 67 degrees. Now we got to come up with our reference angle. You didn't show me how to get this, and that's what we want to make sure we know how to do. So I'm going to add that to your paper. So we know that this is 0 or 360 degrees, and this is 270 degrees. We're down in the 4th quadrant. The angle we want starts at the positive x here We go around the origin counterclockwise until we get to that displacement vector. That big arc is what we're looking for. That's the theta that we need. This is in quadrant 4. Quadrant 4 angles are between 270 degrees and 360 degrees. Notice that the angle we want and the angle alpha together get us all the way around to 360 degrees. You see that? They make the full circle. So to get the angle we want, we're going to take 360 degrees here and back it up by the angle we just calculated. And that is the correct. So that is our final answer, 8 meters, 293 degrees. Okay. Questions? Overall, really good. Just be careful of those couple little things. Okay. All right. I just want quick, you can pack everything up except a pencil. You're not going to be sitting in that seat for much longer. Our lab, you're going to be up and moving around. But before we do that, I want to just, can we zip the lips? We don't need to be talking while you're packing up. I want to just mention a quick thing about your test yesterday. They're graded. They're in Aspen, the scores. You will not get it back until every student of mine has taken it. It's going to take a couple days because I have some kids who are out sick. So when they're back, then they'll take it, and then I'll hand it back to you with the grade. Overall, I was pleased with the scores. But I know some of you, when you see your test, you're going to be face-palming yourself. Why did I do that? You're going to see how picky I was in grading things. Right? Didn't I just say, if you don't show the equation, can I give you credit for that? You leave off the sig figs at the end, you lost credit for that. You didn't show me the givens, and I told you to show me the givens, you lost credit for that. Okay, and those points on constructive response, you can't ever get them back. There is no corrections on constructive response. The only things you can correct are multiple choice. And most of you did really good on the multiple choice. There's only a couple of you that I was like, uh-oh, we got a problem here. And I'll be talking to those students individually once I hand back the test about their coming in for some help because they're not getting it. Okay. But overall, pretty good. I expect test 2 to be even better because now you know what it's going to be like. You've taken one. It shouldn't be a surprise anymore what's going to be there. The format, the wording of the questions, that kind of thing. It's all the same. Okay. Our lab today, lab 4, is a lab that involves some toys. And we're going to break up into 6 groups. You're going to clear your desk. We're going to move in a minute to go sit with your groups. That's why I said pack it all up except for a pencil. So, Muhammad, I want you to start counting us off. We're going to go into 6 groups, so we're going to count off up to 6. So you're 1. And then Colin is 5. 6. After 5 comes 6. Okay, I'm going to have you move. I would like all members of group 1 to sit here. All members of group 2 to sit here. All members of group 3 to sit here. 4 is going to sit at the end of this side. 5, they're all going to sit here. And 6 will sit at those 2 benches. Take your things with you. Just keep out a pencil for now. Yeah, I think so. So 5 is over there, back with. Take all your things over there. one member of each group is getting a stack of Post-its. And I am assigning you as Post-it person. You're probably not going to like this job in a few minutes. But, oh well, we all have jobs to do. Sometimes we don't like them. Okay. I would like you, those of you who have the Post-its, you're going to write some things on your Post-its. Let's go. The top Post-it, put 0 seconds on it, or 0S. The Post-it underneath that, write 2S, 2 seconds. The Post-it under that, 4 seconds. The one after that, 6 seconds. The next, 8 seconds. Then 10 seconds. And the final one you need says 12 seconds. Tear that stack of Post-its off the pack. I'll get the rest of the Post-its from you. Keep them in order from 0 to 12. Stack one on top of the other. Stack them up. Take that one. Stack from 0 to 12. That's in order 0 to 12. Okay. Each of your groups is going to be given a little car or buggy. On it, there is a number. Those of you with the Post-its have to write down that buggy number on the other corner, one of the bottom corners. So that way, when these are all the Post-its are going to be down in the hallway, you know which Post-its belong to your group. Okay? So your group is buggy 5. So put a 5 on every Post-it somewhere. Your group is group 4. So you have 4 on all of those. Write 2 on all of those. Don't play with it. You break them, you bought it. And these are not cheap. They're about $35 a piece. Yeah, you break it, you bought it. So do not mess with them. Don't play with them. Your group is assigned 6. Your group is assigned number 1. And you guys are assigned buggy. Okay. So one person gets the buggy. Next. Okay, so Hudson, you've got the buggy. So you've got the buggy, Jackson. So Muhammad, you're going to get the buggy. No, you've got the buggy. And Helen, you've got the buggy. Okay, the other person in the group. The next person in the group needs a Chromebook. Take out your Chromebook. The next person in the group, pull out your Chromebook. You brought all your stuff with you, right? Isn't that what I told you to do? Bring your stuff with you to your seat because that's where you are the rest of the class. And take out your Chromebook. And I want that next person in the group to open up Chrome tab to a stopwatch. So just Google stopwatch, and you should get a stopwatch app. Something that you can just press start and stop, and it will give you a time on the screen. Please don't. No, I'm serious. You want to spend $35 on a toy that doesn't work? I don't think so. All right, so every group has a stopwatch open? Okay, let me explain to you what we're going to do. Each group is going to be given, you've got your buggy. They all move at different speeds. We're going to be looking at them moving at different speeds and different directions in the hallway. And what you're going to be doing, I'm going to open up this metric measuring tape, which is 10 meters long. I'm going to tell you where you're going to start your buggy and in which direction I want you to have it headed. The person with the Chromebook has the easiest job. They press start, and then their job every 2 seconds is to count off the time to the group. So, Nathan, what you're going to be doing is you're going to say start, 2, 4, 6, 8, 10, 12, and then you can set your stopwatch. You don't need any more time after 12. Those of you with the Post-its have the hardest job. You have to put the Post-it down where the buggy is on the floor at each of those times that are called out to you. And some of these move pretty quick. The person with the buggy is in charge of turning the buggy on after the 12 seconds, picking it up, stopping it, but also the other person in the group is also helping keeping it go straight. You're going to need a couple people in the group to help with that, to keep the buggies going straight. All right, and you may even have to help with the post-it piece. First thing we got to do is just get them on the floor at those times, and it's tricky. Once we have that, we're then going to, I'll show you, I'm going to help one group figure out, and you're all going to watch how we write down positions on each of those. Your entire group at that point has a pencil, so that way you can work collectively to write down the location, the position of your buggy along the measuring tape at each of those times. I'll show you how to do that. I'll do that with one group for a couple of measurements. You'll all watch. Pay attention, so that way you can then do it with your group, and then you can get them all done. And once you've written your positions down, you pick up your Post-its and you put them in order. We're then going to come back into the room as a class, and you're going to share those measurements. When I call out your group, you're going to read off those numbers, and we're going to put them into a Google Sheet. That way we can collect position and time data for each buggy. It's better than you're just doing one buggy. We're going to share, so we have 6 buggies worth of data instead of you individually or as a group doing 6 buggies yourself. Takes way too long. Okay, does that make sense? You have a sense for what we gotta do? All right, so we're gonna do one group at a time out in the hallway, but we're all going out so you can see, because I want you to see how these buggies are moving, so that way it makes sense to you. When we make our data tables, you'll not understand this was moving fast, this was moving slow, this was going this way, this one was going that way, and so on. Okay? So all you bring out is your buggy, your pencil, and that group person who has the Chromebook. That's it. Everybody else, let's head on out to the hallway, and I'll tell you what we're going to do. Come on in. All right, let's start with buggy 1. Who has buggy number 1? All right, come down. Buggy 1. Watch. I'm going to give the same instructions. Ready to follow? I guess we're going to have to start all over. We only have 3 questions on the ground. So that group, good luck. Let's get it done, and let's get it done quick. We don't have all day. Group number 2. I'm sorry. Buggy number 3. So buggy 3. Who is buggy 3? One down this way. Buggy 3 is going to start at the 10-meter mark. Buggy 3. 4. Buddy 5. Who has Buddy 5? Okay, Buddy 5. We're going to start at the 5 meter mark and head that way. Let's do it this way. So put your 0 here at 5. Did you get them? Are they stuck to the floor or are they upside down? I don't see times on these. All right, so Buddy 5, you're going that way. Same thing. Ready? Okay. Who has Buddy 6? Buddy 6. Okay. You guys are starting at the 5 and going that way. You guys done? Okay, who has Buddy 2? Okay, Buddy 2. You're going to start on this side at 0. You guys are on that side? Okay, which Buddy did I miss? 4. Buddy 4, come on back this way with me. Buddy 4, you're going to start at the 10-year position. Here. And go that one. Pick up your buddies when you're done. Now, just turn it on. Okay. So, can you do it? Tell them to put it down every 2 seconds. Let's do it. This is not hard. Put this way. No, it doesn't. Okay, buggies. Are we done with your buggies? Just put the buggies on the side left hand for me. Everybody else stay here. The front of this. One more. Okay, done. All right. Here's what we're gonna do. Turn the buggy off. Put it on the desk. Buggy this side on the side left hand. All right. Let me show you how you're gonna get your position. Your last step before we can go back to your class. I would like everybody to meet me down at this end of the measuring tape so I can show you how this is. And pay attention, because I am not going to help you. I'm going to show you how to do this twice. And that's it. You have to find your proof post. And what your mouth reads is what you can have a pencil. You have to write down the position on the measuring tape. Attack. So this one, the end of the measuring tape here, this plastic is 0 meters. I see I'm between the 3 and the 4 in red. So it's between 3 and 400. I come up and I see it's right about here, which would be 327. And that's what we're getting written on this post. Do you understand what I have to do? Okay, all the post-its have to get their values on it in centimeters. And then pick them up as you write it and do your group. That way they're all above the floor. And then we can go back in the room. So find your group post-its, get them written down as a group. Each help do that. Let me know if you're getting stuck. So that would be 1,000 or 1,000. Right? 1,000. Right? 1,000. So the 0 is. And then you can go back into the room as a group, okay? Put them in order, 0 to 12 seconds. Oh my God.
Skis fish for 1.97
Great. Actually wasn't that bad. Yeah.
It's better than sitting on school. Like, it's crazy. The back sport to do for you.
Oh, you guys sit up there? I don't like it.
But I don't want to.
I feel like I'd rather sit in the stool than
No,
you can have my
no,
stool.
no.
I don't like my stool.
Like, you change positions like every 2 minutes.
I feel like it depends how tall you are. Like, I'm like, well, you're tall. I'm tall. You guys are both tall, so you guys have to kind of like push over the right.
Yeah. I like leaning back on the sink to get some sort of back support. It takes it on its thing.
All right, everyone now needs a Chromebook. Sitting as a group, right? Everyone needs the Chromebook out now. And open up Lab 4, because now we're going to share data with each other and populate the data table. And that's our job today, is to get all the data in the table. So we look at Lab 4. There's a Google Sheet that was pushed out. Come get it. All right, in this data or in this Google Sheet, you'll see that there are 4 tabs along the bottom. We are going to the experiment tab, please. Open up the experiment tab. And you'll see that this is the table that we're going to populate right now. So I'm going to call out the buggy number and the time, and you're going to, whoever has that post-it is going to tell me what the time or what the position was in centimeters at those times. So let me make this a little bigger because we're all typing in the same numbers. Okay, buggy 1. Where's buggy 1? Okay, Colin, go ahead. 0 seconds. 0. Okay, so these are centimeters. Go to buggy, 2 seconds. 25, 4, 49, 75. I'm sorry, 100 exactly. 10 and 12. Great. Okay, buggy 2. Who had buggy 2? Okay, go ahead, Mia. Yep. 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 Yes. 8. 10. All righty. Let me make this even bigger. Okay, buggy 3. Who has buggy 3? All right, go ahead.
1,000,
Yep.
922,
Yes.
874,
6 seconds.
804,
Good. 8.
737,
10.
646,
And 12.
565.
All righty. Buggy 4. Go ahead.
1,000,
Yep.
950,
I'm sorry, 915.
15,
Okay, 4 seconds.
845,
6 seconds.
778,
8 seconds.
700,
10 seconds.
660,
616.
Yeah.
And 12 seconds.
549,
Very good. Okay, buggy 5.
501,
Yep, 2,
583,
4,
662,
6,
737,
8,
792,
10,
886,
and 12.
936,
I'm sorry, 9,
36.
36. Okay. Buggy 6 had the hardest one. Who's got those? You do? Okay, go ahead, Nikki. 500, 500, 500, 500, 500. And there's one more. Okay, so folks, what was that buggy doing? Not moving. Okay, we need to see that so that way when we start to make graphs, we know what this graph should look like. Okay, so we're going to talk about graphs for things that are moving at different speeds in different directions and not moving as well. Okay. Oh, how are we doing on time? We got like a few more minutes. Can't see my watch. Yeah, we got like 4 minutes, so I think we're good. I want to give everybody a moment to make sure you have all that data typed in, and that's where we're ending. If you have all that data typed in, you're good. You can close this out. We're not doing anything more with it today. We will be finishing this lab on Monday. So we all need the data for that. What is your homework tonight? To study. No, I'm going to collect those post-its up. As long as they're all entered in correctly, we're good. I'll throw them out. So you can pack up your things. Whoops, somebody's water bottle. See what that is. Thank you. Excuse me. Stay at your seats, please. No belling. Please, no belling. Excuse me.
Yeah, I hope you know
Mine
like
is
water.
just to show like data.
Josh, you know something? I would- Like,